Hello everyone, welcome back to my channel. Today we will dive deep into a very interesting problem: maximum number of operation to move ones to the end. Basically, this problem looks simple at the first glance, but it hides a beautiful greedy plus counting pattern inside. By the end of this session, you will understand not just the code but the reasoning, why it's work, why other solution fail, and how to think in zero and way to avoid time limit exceed. So grab your coffees and let's get started. The concept is you are given a binary string S contain 0 and 1. You can perform certain operation where a 1 can move past zeros under a specific condition like defined by the program statement. The goal is to find the maximum number of valid operation you can perform. So in simple word, each one try to move to the right side of the string and we need to count how many total valid moves can happen. Before all ones are pushed toward the end, let's intuitively understand what happens when you traverse the string. Every time you encounter a 1, you can store it like because that 1 might move across 0 letter. Every time you encounter a 0, it can be crossed by all ones that came before it, but not every 0 give a valid move. Only when it followed by 1 or it's the last 0 in the string. So here is the key idea that we will move to the greedy observation. We only perform an operation when a group of 0 ends. That happens when we are at the last character or the next character is 1. At that point, everyone seen so far can perform on move over that 0. So for every 0 that in the 0 block, and we simply add the number of the 1 is seen so far of the answer. Okay. So this greedy observation helps us calculating everything in the past. So here is our code. Okay, we will move line by line. Okay. So in the first line, there is a class solution, diff max operation and such on. Okay. So let's dive line by line. So in the first class solution, here we define a class solution. This is just a container for our function as required by platform like Leetcode. In line 2, diff max operation self comma s. Here we define the main function max operation which takes a binary string s as input. Our task is to return an integer, the maximum number of valid operation. So here in the line number 3, 1 is equal to 0. We initialize a variable 1 to 0. This will track how many 1s have appeared so far in the string. Every 1s before a 0 has the potential to jump over it. So we must keep track of them. In the line 4, ans is equal to 0. This will store our final answer, the total number of valid operation. Okay, in the line number 5, n is equal to len s. We store the string length in n. We will need to check yes I plus 1 bond. Okay, safely. In the line number 6, for I ch enumerate yes. Here we start looping through the string. I is the index and ch is the current character. Either 0 or 1. We are scanning the string from the left to right. A single pass 0 and time complexity. Line 7 to 8. If ch is equal to double is equal to 1, once plus is equal to 1 in the line number 8. Here, whenever we find a 1, we increase our count of ones because every one we have seen so far represent a potential mover. That means a player who can jump over zeros. Okay. In line number 9 to 11, else where we have just check a condition that if this 0 is at the end or next carries 1, it's a useful 0. Okay, and if if I is equal to n minus 1 or yes I plus 1 is equal to 1, and also n's plus is equal to 1s. Now comes to the most important part. Here we found a 0. Not all zeros matter. We only care about the last 0 here in a block of zeros. So we check if I is equal to n minus 1. So it means 0 is the last character, or yes I plus 1 is equal to 1. That means the next character start a new one section. Both of these mean what? This 0 marks the end of a 0 block. At this point, every one seen so far can like jump over these 0 ones. Okay, so we add ones to our answer. This is the essence of the gradient step. Okay, so we don't simulate moves. Okay, we count how many would happen. Okay, so in number in line number 13, return else. Finally, we return our total count, the maximum number of valid operation. Here is a lot of example is there that input yes is equal to 1001101, and input will be like explanation. Here is the explanation. Okay, we have just run this code, and final answer will be what? 4. Okay, so it work efficiently. Like the algorithm is 0 and because we only loop once over the string. We don't simultaneously swap or build new string. Like each character is proceeding the constant time. Like this prevent like the TL event for a string with length up to like 10 to the power 5 or 10 to the power 6. Okay, there is a problem in the code that it will like time limit extra, because I am just solving this question in like Python. Okay, so it can take some time, but it will be solved in the like 1 hour. Okay, here the memory use like 0 1. We only use we only use a few integer variable. Okay, so we have to talk about the common mistake. Okay, simultaneous moves like swapping 1 or 0 repeatedly. This causes 1 n square time complexity and fail last input. Okay, so counting like logic ready approach. Okay, we avoid simultaneous and directly calculate moves using the like pattern recognition. So in this question, final summary is to summarize the that step concept. Okay, like in first step, count how many ones we have seen so far. In second step, whenever a 0 ends a block, add those ones to the answer. In third step, continue until the end of the string. In the fourth step, like the total count is our final result. Okay, so that's it from our side. Okay, friend, so we have just successfully solved the maximum number of operation to move ones to the end problem efficiently and elegantly. Okay, so we have learned like how to think greatly, how to convert simultaneous into the counting, and how to write 0 and optimization code that pass all the test case. If you find this breakdown helpful, don't forget to like, subscribe and share this video with your coding buddies. See you in the next one. Happy coding!